Dear students, welcome to s.mathguru classes. Our main discussion is linear differential equation second order with constant coefficient. Last video some problems done. If right hand side 0, then we can easily solve, but right hand side is non-zero number. It may be exponential, it may be algebraic, it may be trigonometric. Then we have to find particular integrals. Now let us consider some rules how to find particular integrals. If e to the power x given, e to the power something given, or sin x cos x given, or exponential with algebraic given, or simply algebraic given. Now how to find particular solution? So rules to find particular integral. Number one, suppose denominator is in terms of fd given, d given, and e to the power ax. This coefficient of x a putting in place of d, then we get particular integral. If exponential function given, e to the power x given, coefficient of x is x is a, putting in place of d, we get this. And if after putting in place of a, in place of d, if we putting a, if this result is 0, then we taking one x and differentiate this and putting this a here. So we differentiate the denominator with respect to d and taking x in numerator and putting the value a, coefficient of x, in place of f dash a. Again if it is 0, again f dash a equal to 0, then again we differentiate this and x into x, double x given in numerator, and we differentiate second times and putting the value of x, putting the value of coefficient of x is here. Second derivative 0 means we putting again a here and giving another x. First one is x, again multiplying by x in numerator. This is the rule. If algebraic given and this is in terms of d, then this one taking in numerator, power will be minus and x to the power n, we get this. If trigonometry only sin and cos, sin ax given, putting this a, coefficient of x is a, putting this a in place of d and with minus sign, d equal to a, putting with minus sign. If it is cos, then putting a here with minus sign. This is the rule in case of sin cos. And if it is 0, then we multiplying by x, numerator multiplying by x, and differentiate this with respect to d and putting this value and with minus a, minus given and a square, d equal to a square putting. And if it is exponential and another function mix up, then exponential taking outside and coefficient of x is a, putting d equal to d plus a, and we calculate and by the rules of above rules we using here. And if it is d plus 1 by d plus a phi of x, another function, then we write this e to the power a minus x, e to the power x, integration phi x dx. These are the rules. When you have to solve some problems, you always maintain this rule and obey this rule. If the right hand side is non-zero, we have to find particular integrals. Particular integrals, these are the rules. Now let us consider one problem. Consider this problem: d plus 3 whole square y equal to 25 e to the power x. Right hand side is non-zero given but exponential given. Now solution, first we find auxiliary equation. Here in terms of d given, auxiliary equation equal to m plus 3 whole square equal to 0. This is m equal to minus 3 minus 3. If we write shortcutly, this is m plus 3 into m plus 3 and both will be 0, then we get minus 3 minus 3. Therefore, complementary function equal to, roots are equal, we get c1 c2x e to the power minus twice x. We get this is our complementary function. Now particular integral pi, this is right hand side 25 e to the power twice x by d plus 3 whole square. This is fd, this one. So the rules is e to the power ax and fd, then putting a in place of d, e to the power ax, this will be f of a, just putting d equal to a. If it is non-zero, after putting the value 25 e to the power twice x and putting d equal to coefficient of x is 2, putting 2 plus 3 whole square, 25 e to the power twice x, this is 5 square, 5 square means 25, this one cancel, we get e to the power twice x. This is our particular integral. General solution is y equal to cf plus pi, y equal to cf plus pi, we get this, and this implies cf means this one complementary function, c1 plus c2x e to the power minus thrice x plus pi e to the power twice x, and this is our final answer. Very easy solution, very interesting. Consider this problem, d square plus 9y equal to e to the power twice x. Now I want to solve this problem. First we find auxiliary equation, this equal to m square plus 9 equal to 0. M square equal to minus 9, m equal to plus minus root over minus 9, m equal to plus minus 3i. Root over minus 1 means I and 9 means 3. So roots are complex. Therefore, complementary function equal to a cos x 3x plus b sin 3x. These are complementary function because roots are complex. Now particular integral, right hand side is non-zero, particular integral e to the power twice x by d square plus 9. E to the power twice x, in place of d putting 2 square plus 9, and this is e to the power twice x, 4 plus 9 13, we get this is our particular integral. Now general solution, therefore general solution is y equal to cf plus pi, y equal to cf a cos thrice x plus b sin thrice x, and pi means e to the power twice x by 13, and this is our answer. Very easy solution. This is our answer. Consider this problem, d square y dx square minus a square y equal e to the power ax. Now solution, this equation can be written as d square minus a square y equal to e to the power ax, because d square means d square dx square. So d square dx square and d square and y common. Now auxiliary equation, m square minus a square equal to 0, m square equal to a square, m equal to plus minus root over a square, and m equal to plus minus a, we get this. Therefore roots are unequal. Therefore complementary function equal to c1 e to the power ax, c2 e to the power minus ax. These are complementary function. Now I have to find particular integral pi. Pi is right hand side by this one. Now if we putting this coefficient a, x coefficient of x is a putting here a square minus a square, we get denominator 0. If denominator is 0, then we differentiate this with respect to capital D. If we differentiate, we get twice D, and multiplying x in numerator. This is e to the power ax. When you multiply numerator by x, then we differentiate this. D square, if we differentiate it twice D, and this is constant 0. Now putting a here, twice a x e to the power ax, we get this particular integral. Therefore, general solution is y equal to cf plus pi. This implies y equal to cf. Cf means this one, c1 e to the power ax, c2 e to the power minus ax plus x e to the power ax by twice a. We get this, and this is the answer. Answer is this one. Complementary function plus particular integral. Then this is the answer, and this is very nice solution. There are students, these are very interesting, very enjoyable problem. Anyone, no one can say this problem is difficult, and these are most important for BTech courses, any engineering courses, and BHC major also, major pass course both. If second order derivative, second order differential equation given, then we have to practice this type of problem. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.